Hello, and welcome to our talk. I'm Derek.
And I'm Felicia.
And we are both software engineers at VMware. And we're here today to talk about what's new for services in the V3 API. So here's briefly the agenda. We're going to talk about some of the new concepts available on V3. We'll talk about service brokers. We'll talk about service plans and offerings. We're also going to talk about service instances, what's new there, user-provided service instances, service bindings, and then we will touch a little bit on what's coming next for the CLI and what's the new experience could be for the CLI. First, if you're curious about why V3, there is this very good talk on the last CF Summit. It was actually a panel discussion with the V3 acceleration team where they go through a few of the reasons behind this refactoring. So if you're curious, go there, it's pretty good. So let's start by talking about synchronous and asynchronous operations. So what are synchronous operations? Synchronous operations are that one that block once a request is received. So CAPI received that request and will not do anything until that request is completely fulfilled by the service broker, for example. Asynchronous operations are the one that the cloud controller will return before actually finish it up. Before all the process has been done to that particular request. For some of the services, for the services part of the API, operations usually involve a service broker, right? SAPI defines a query program called a SAPI incomplete that platforms talking to brokers can provide to determine how the broker should respond. On V2 endpoints, we had a quite inconsistent approach to how we deal with that. A few of our endpoints, like the create service instance endpoint, would accept an optional accepts incomplete query param that would then be passed directly to the broker. We had some other endpoints that would synchronously call the broker, and we have some other endpoints that would potentially talk asynchronous to the broker. On V3, we decided to simplify those interactions by taking the simple approach of, is any communication required with the broker? If that's the case, it will be asynchronous. So the client that is talking to CAPI will receive a 202 accepted, unless the request is invalid and all of that, with a job that they can use to pull. Any request to the broker will be sent with the accept incomplete equals true. So CAPI will always request asynchronous when possible for the broker. On the other hand, when communication is not required with the broker, it will usually always be synchronous and will return no job. Yeah, so there's like different resources change slightly different on how they're going to do the sync versus an async. So if you're curious to know more, I recommend going to the API docs for a particular endpoint. That should tell you what to expect. Next up in our list is service offerings. So this might be actually the first time we talk about service offerings. On V2, service offering was actually the service resource. And as you may have noticed, the service word is a little bit overloaded. It's sometimes a service instance, it's sometimes a service offering, there's service plans, there's service access, there's services everywhere. So to try to reduce that ambiguity, at least on the API endpoints, we decided to rename services to what they actually are, which is service offerings, which is like the services that are available for developers to use in the platform. Hopefully it's a little bit more clear. Yeah, there is some CLI commands that are still called service, but eventually we hope that those could also change. Service offerings, next, like service offerings have service plans. Not a lot has changed in the service plans themselves. But we're going to use service plans to bring up some of the other changes that we introduced that would make life of API users a little bit easier. And for that, we consider the CF marketplace command. So marketplace is a simple command that should be simple, that runs, get a list of services, and outputs the services, the plans, and the broker names. On V2, it's achieved by sending a GET request to that space services endpoint, which is an endpoint that is created basically for this marketplace command. And for each one of the service, we send a GET request to get the service plans. While in theory, it doesn't look that bad, it has a few API problems, a few design problems. So first is very shoddy. So you have, the more services you have, the more requests you need to send, because you send one request per service to get the service plans. It also breaks a little bit of abstractions. We added that space services endpoint just because the alternative was a little bit too bad, and the command would like take ages to complete. And another problem is that in general, is that when you get things from, when you get the services, you get GUIDs instead of names for the related resources. And then usually clients want names when they want to show that to users. So what V3 introduced is this concept of filters, includes, and fields, which allow clients to change what the response will look like. So for example, you can add extra information or you can remove information, and you can also, it also allows the API to hide some of the sensitive data when appropriate. And the way we use that on CF7 Marketplace, it's by basically sending a combination of filters, includes, and fields to, in a single request, get all of the information that the API needs, that the client needs. So you can see that in this particular request you have here, we are getting all the service plans, filtering byte space, including in the response the service offering, and then also through the service offerings, including the service broker name. And that allows us to run a much faster CF Marketplace command. Next, we have service plans visibilities, which is usually hidden from the developers, but it's kind of front of mind for admins as well. Service plans can be public, restricted to some orgs, restricted to some space, or only available for admins. That determines like what user can actually use that particular service and that particular plan. To determine that visibility, the client needs to look in different places. So we have a property called public that can be true or false in the plan itself. We also have another resource, which is service plans visibilities, which is a little bit of a leak of our database model that you can query to determine what are the orgs that are available for that particular plans. For if it's space scoped, it's actually not that straightforward. So, and also to change that plan, the visibility of that plan, we also need to change in multiple places. So for example, to make it admin only, we might need to change the public property and delete some entries in the service plan visibility. And that can cause like a lot of problems. It is one of example of an issue of a client with tons of orgs. And it's saying that's like the service access command can take an hour and sometimes it times out. Ugh, terrible. But hey, it's all fixed now with the visibility type. So the first thing we did was to actually simplify or add a property that tells the client immediately what's the visibility type for that particular service offering, service plan. And that can be public, admin, organization, or space. And he also made it simpler for users to change by sending a single request to CAPI, and then CAPI will take care of synchronizing all of the things that need to be synchronized. And V3 service plans visibility is not a thing anymore. It just doesn't exist. Yeah, and then when you use that in combination with fields and includes, we can vastly like simplify the number of requests that is needed to run like CF service access command, for example. You can see that it's the same environment. The one on the left has 4 requests, which is the CF7 command using V3 endpoints. The one in the right has, I think, 50 something commands and takes much more time. It takes much longer to actually execute. Cool. So we can now talk about a little bit about service instances. The first thing we did was to, again, simplify the number of endpoints we have. So we just merged the 2 types of service instances into a single endpoint. And of course, you can use filters to get only the ones you want. And you can, and when you are creating, you need to make sure that you send the appropriate body so you can create the appropriate type of service. But more important than that, we also changed how create behaves in the API. So basically, the V2 implementation has a few problems. The first one being the initial provision request to the broker is synchronous. So we wait for the broker to respond before responding to the client, but that initial request can take a long time and the client can time out. And also the way we create jobs, the way we structure the jobs makes it quite impossible for people to follow through a particular job. So on V3, we changed that by making, like, as I said before, if it needs the broker, it's async, and it creates a job immediately, and that job goes through different states, processing, pooling, succeeded, failed, and that would allow clients to more confidently follow through the jobs to provide whatever UX they want to provide to the users. We'll touch a little bit more about that next. Not next, but later today. Stay tuned.
Okay, the next important operation after creating a service instance is using it by creating a binding that can be for the purposes of binding that to an app or creating credentials for that service instance. As a disclaimer, all the updates that I'm going to be talking about right now, they are still in a proposal stage and you won't find them implemented, so you're still welcome to give us your feedback on the resources. As we know, the service bindings have a rough mapping from the SAPI spec into the SAPI endpoints. However, the underlying operations are very similar. So in V2, creating a service binding would mean creating an SAPI credential binding type and sometimes also including a log drain and a volume mount type. And on the other hand, creating a service key is very similar subset of this, but it creates a credential binding type without binding it to the app. So we found that the differences of these bindings were not very clear unless you knew the behind operations of the cloud controller and SAPI. And what was clear was the fact that they were doing essentially the same SAPI operation. So we decided to bring the bindings resources more in line with what SAPI defines as a binding type. And now the service credential binding is the new resource that represents an SAPI binding type of credentials. And then you can use the type key or app to define which one you would like to use. Another issue that your users who are facing when using the V2 API is the amount of different endpoints that you have to go through in order to build the full usable pictures. As an example, there are 6 different get endpoints to give slightly different information about service bindings. And that means that even simple client operations such as get all bindings and all apps and instances that they relate to would request a lot of different endpoints with very different response types and styles. Following the same principles as the rest of the API design, we have concentrated all the functionality on a single endpoint that has one consistent response and that can be manipulated using filters, such as selecting the type of the bindings and its relationship with the service instances or apps, if it has any. And it can also be extended by using includes so that you can receive the service instance and the app at the same time as receiving the bindings. Also, as Derek mentioned before, in V2, we relied heavily on accept incomplete to communicate to the broker and to implement the asynchronous features of the broker. However, because these endpoints were all separate, it meant that not all changes were propagated with all the resources. So service keys in V2 could not be created in async fashion, which becomes even more of an issue as more and more brokers are embracing the async behaviors. So as other resources mentioned so far, this resource also communicates completely in async fashion with the client and the broker. Another addition to this resource interface is the separate endpoint to retrieve credentials, which allows the API to be much more transparent about the permissions model. There will be no redacted fields, which means the user either gets the entire resource or it doesn't get it at all, and it makes it harder to accidentally leak credentials. On the other side of bindings are root bindings, which are also in a proposal stage. So in V2, these bindings were implemented as a relationship between service instance and the root, which is easy to understand, but not very easy to implement and extend in line with the new features of SAPI. So in V3, we decided to give root bindings its own resource, which is called service root bindings. that will create an SAPI binding type of root service and allows us to implement features such as async bindings. In V2, the only possible operation was to just get the list of all the routes for a service instance. And again, following the same API guidelines, you can now do much more manipulations using filters and using includes. Another thing we wanted to talk about today is sharing with you our lessons that we learned as part of not just implementing the API, but also using it in a client such as the CLI, which has been quite an important feedback mechanism for us. As a result of the improvements in the API interface, we've been able to provide a much simpler CLI flow. As you might remember, this API used to offer summary endpoints that would be modified to match new feature requests. And while they were quite useful in getting new pieces of information on demand, they were also not standard and they were confusing to work with. What we achieved with the new standard API is that the CLI client now can use a mix of fields and filters and includes to achieve the same output in many less requests. And also all the responses are standard, which means that the knowledge and the code can be easily reused between different resources. And one of the most important requests on the CLI features has been the addition of the wait flag to give users the option to wait on operations rather than keep pulling on another command. And with the addition of asynchronous behavior in every V3 endpoint, now we can exactly follow the same job that a command started and make decisions on the user experience, how to translate that job. I hope you have enjoyed our talk, and if you want to continue the conversation with us, we're monitoring the following channels. We are still waiting for feedback on our binding proposals, and you can open new GitHub issues or just give your voice on the old GitHub issues on Cloud Controller and CLI, and you can talk to us directly on our Cloud Foundry Slack channel, SPAT. Thank you.